Okay, so we're looking at our next induction type. The first type we did was sums. The next type is divisibility. And again, some of the steps are the same. The last step is a little bit different. So for instance, we might have to prove that 3 to the power of 4n minus 1 is divisible by 80 for all values of n. So you don't have to worry about where these formulas are coming from or why it's divisible by 80. Someone's done it for you, and we just have to do the proof. Okay, so that's an example. So copy that down and then come across. Okay, so step 1 and step 2 are the same, and step 3 involves more thought. Now that's very vague, but this is where you have to do some thinking about what divisibility means. And so for instance, if something's divisible by 2, then it's 2, 4, 10, etc. And how you define that is you just say, well, it equals 2 times something. Okay, so if something was divisible by 11, so you got 11, 22, 121, etc. How do you define that? Well, you say it equals 11 times some number. So this number is like the coefficient of some other number, and we don't know what that number is. We don't need to know. It's just going to be a factor. Okay, so come across when you're ready. Okay, so I've done the first 2 steps. So step 1, n equals 1. Well, you just put 1 where n is. So 3 to the 4 minus 1. 3 to the 4 in your calculator is 81 minus 1. 81 minus 1 is 80. And then obviously 80 is divisible by 80, so it's true for n equals 1. The second step is you assume it's true for n equals k. And as I said on the previous page, you just say it equals 80 times something where m is some integer. You don't need to know anything more than that. Okay. So what we do now is I'm going to show you 2 methods, and they're both valid. Okay. So what we're going to do is where the n is, we're going to put k plus 1. Okay, so 3 to the power of 4k plus 1. And then it says minus 1, and that is going to be divisible by 80 in the end. So the next step is we've got index laws. So we've got 3 to the 4. Now, because we've got a... I'll do it in steps. 4k plus 4 minus 1. So I've got 3 to the 4k, and that's going to be multiplied by 3 to the 4. Because when you had a plus, if you had a multiply, then you add the indices. Okay. Now, unfortunately, I'm going to make that a bit smaller because I'll have to get page extender up on my next video. So I'll just make that a bit smaller. Oh. And I've lost it. So sorry about that. So I'm going to just grab it again. And it's making it too... Okay. Make it up a bit. Okay. So I've lost some of my formatting's a little bit out, but that's okay. I'll just keep moving on. Okay. Now, so don't... I'll just crop that out. So looking at this expression here, I've got 3 to the 4k times 3 to the 4 minus 1. But up here, I said that, and actually I've got to make that the subject. So 3 to the 4k equals 80m plus 1. So now I've got expression for 3 to the 4k. So then I say over here, I've got 80m plus 1 times 3 to the 4 minus 1. And then I can multiply that out. So I've got, just looking at what I've got. So 3 to 4 is 81. So 81, so that equals 81 times 80m plus 1 minus 1. Now I don't need to multiply that because that's going to be my factor. So 81 times 80m. Now 81 times 1 is 81 minus 1. Equals 81 times 8m plus 80, and there's my 80 back again. So then I take out the factor 80, which appears in both numbers. So I'm left with 81m plus 1. Okay, and again, I'm just going to make this a bit smaller. I'll get my thing fixed the next one. Now, that is your divisibility because this number here is going to be an integer. So therefore, it's divisible by 80. So then we can say, therefore, true for all values. Now, in method 2, it's a slightly different step. What we're going to do is we're going to prove that the difference between the terms, okay, so if we can prove that the kth term, if we can prove that the difference between those is a multiple of 80, okay, that's all we need to prove. So slightly different setup. So tk plus 1 is same sort of setup. We've got k plus 1 minus 1. So we've got 4k plus 4 minus 1. Alright, so that's all we've got so far. Now, tk we've already got from previous, so that was just going to be 3 to the 4k minus 1. Now, tk plus 1 minus tk equals 3 to the power of 4k plus 4 minus 1 minus 3 to the 4k minus 1, and then we can just do the same. Okay, so you got minus 1 minus minus 1, so the ones have gone away. So you end up with 3 to the 4k plus 4 minus 3 to the 4k. So then we expand, so we've got 3 to the 4k bracket 3 to the 4 minus 1, and then as we've done that before, 3 to 4 minus 1 equals 80. Therefore, the difference between the terms is a multiple of 80. Therefore, true for all values of n. So again, this one here involves a subject change. So you'll have a subject change, and you'll end up with, it'll always work out to be a multiple wherever you need it. And with the second one, you have to prove that the difference between the terms is your sort of divisibility. Okay. So there'll be some practice on those on Moodle. Okay, thanks, bye.